This is the lecture for lesson 24. The first part of this lecture will cover parabolas with vertices at the origin. So we'll identify some key components from the graph, from the equation, and then we will graph them as well as write the equation of that parabola in standard form. So here's some different parts of a parabola. This first graph here is going to show us the parabola here, which is this U-shaped function. We are going to have a vertex. The vertex is either going to be the lowest or highest point depending on which direction it opens. We have a focus. We have a directrix, which is going to be a line. We have a latus rectum, which is here. And we also have an axis of symmetry. So a few different options we're going to have here. We can have an x squared parabola, or we can have a y squared parabola. And we're going to put these in this form of the variable squared equals 4 times p times the other variable. Now, if that p value is greater than 0 or positive, the graph will open up in an x squared. If it is negative, the graph will open down in an x squared. If we have a y squared, these are going to open to the right when it is positive or to the left when it is negative. Now that p value is going to help us determine these additional points to create our parabola. So we will use that p value to find our focus, our directrix, and then the endpoints of our latus rectum. So the way that it's going to work is we're going to start with plotting the vertex. We will go towards P is going to give us our focus. We'll go back P, that's going to give us our directrix. And then from the focus, if we go over 2 P's in both directions, we are going to find a point on each side, which is then going to let us create our parabola. The first thing we're going to do is just look at some graphs here and determine where the directrix is and where the focus is. So the focus is going to be this point inside of the parabola here. And that focus is at the coordinates -3, 0. Now the directrix is going to be exactly the same number of units the opposite direction of the vertex. So the vertex is 3 units this way. The directrix is going to be 3 units the opposite direction. So the directrix here is a vertical line, which is in the form x equals, and it goes to the value 3. I'm going to do the same for the next 2 graphs here. So we have B, here is our vertex. And we can see our directrix is drawn up here at a value of 5. So the directrix in this one is a horizontal line, so that's going to be y equals 5. Now, if we went up 5 for the directrix, we need to go down 5 from the vertex to make our focus. So our focus here is 0, -5. It's always the same distance between the vertex and the directrix and the vertex and the focus. And then our last one here, here's our vertex, here's our focus. We are at 1, 2, 3, 4, 0. And our directrix is going to be 1, 2, 3, 4 back here, -4. And a vertical line is x equals -4. And remember, you don't have to have these memorized. You can always copy this table into your notes and have it ready to use when you're doing your homework and your test. The next thing we're going to do is pick out the focus, directrix, and endpoints of the latus rectum when we have our equation. But we need to make sure it's in the form y squared equals everything else on the other side, or x squared equals everything else on the other side. So before we can do anything, it has to be in that form. So looking at A, we have y equals -3/4 x squared. So right now, this is not solved for x squared. So in order to get x squared by itself, if I want to get rid of a fraction, I'm going to multiply both sides by the reciprocal. So I'm going to multiply by negative 4/3. So I have negative 4/3 y equals x squared. Now I'm in the form that I can pick out all of these pieces. I need it to be x squared equals. In order to find the focus, the directrix, and the endpoints of the latus rectum, I need to find the p-value. And the way we do that is what is in front of your single powered variable has to be set equal to 4p. So negative 4/3 is going to equal 4p. Every time our goal is to set it equal to 4p from here so that we can solve for p. So if I'm going to solve for p, I need to divide all the sides by 4. And if I do that, I will get p equals negative 1/3. Now I can use this p and what we have from our equations over here to find the different pieces we need. So this one is x squared equals 4py. So I'm going to use this guy here. X squared equals 4py. So the focus is 0, comma p. So 0, negative 1/3. The directrix here is y equals negative p. So y equals, well, the opposite of negative 1/3 is positive 1/3. And then to find our latus rectums, we are going to take plus or minus 2p and then p. So plus or minus, if we double p, that's 2/3. And then the regular p is negative 1/3. So let's try the next one. For b, again, we have x squared, and this one is set up for us. X squared equals negative 2y. So we're going to follow the same formula here and figure out what is p. So step 1, get it into x or y squared. Step 2, solve for p. And then 3, we can find all these other pieces, f, d, and latus rectum. All right, so we're going to set 4p equal to what is in front of the single variable here, negative 2. So to get p by itself, I'm going to divide through by 4. And that's going to give me a negative half. Once I have that, I'm just going to follow my formula here. So the focus is 0, comma p. So 0, negative a half. The directrix is y equals negative p. So y equals the opposite of negative half is positive a half. And then our latus rectums here are plus or minus. So double this value. Well, if I double a half, that's 1. And then plus or minus p, so negative a half. And we'll do one more here. The difference is that we have a y squared here equals 6x. So now we're going to use this top guy. Same process. It's solved for y squared. So now we're going to solve for p. So 4p equals what's in front of the single variable. So 6. 4p equals 6. If I'm going to solve for p, I need to divide by 4. So when I do that, p is equal to 3/2 if I reduce that. So now I'm going to use this top line for focus, directrix, and latus rectum. So focus in this case is p comma 0. So 3/2, 0. The directrix is x equals that p value, 3/2. Then we'll follow our latus rectum is p, so 3/2, and then plus or minus 2 times that. So 2 times 3/2 is just 3. And that is how we would do it. Now that we have seen how to find the focus, directrix, and endpoints of the latus rectum, we can go ahead and also graph the parabola. So our first one here, x squared equals negative 8y. So we're going to be doing this guy, second one down here, x squared equals 4py. We have it equal to x squared, so we're going to set 4p equal to negative 8. And if we divide by 4, p is equal to negative 2. we know our vertex is at the origin, so I'm going to place that there. Our focus, I'll go down here, is 0, -2, so 0p. So there's our focus. Our directrix is going to be y equals the opposite of that, so +2. So we'll have our directrix here. And then we need the endpoints of our latus rectum. So we are going to write positive or negative 2p. So positive or negative 2 times p is going to be 4. And p is -2. So +4, -2. 1, 2, 3, 4, -2. And -4, -2. So here's our focus. We're going to go from our vertex through these points, and we have created our parabola. Let's look at the next one. It is not solved yet. So what I need to do is I need to get this into x squared form. Right now I have 5/4 times x squared. So in order to get rid of that, I'm going to multiply both sides by 4/5. So 4/5 y equals x squared. And now I can solve for p. So 4p equals 4/5. And when I divide both sides by 4, I'm going to get p is 1/5. So we can then find our focus, our directrix, and the endpoints of our latus rectum. We are still working with an x squared, which is this bottom one here. So the vertex is still 0, 0. The focus is 0p, so 0 and 1/5. So 1/5 is going to be real low there. The directrix is going to be opposite of that at -1/5. So y equals -1/5. And then the endpoints of our latus rectum, if we double that, so positive or negative 2/5, and then 1/5. So positive 2/5, 1/5. This one's going to be real narrow here. And you can always adjust the scale. I could have made these not count by ones, and then it may have been a little bit easier to see the points. And if we do C, we have a y squared equals 4x. So it's already solved for y squared. So we'll go look at this top one now. So 4p equals 4, which means p is 1. So we're going to find all of these here after we put our vertex at the origin. So our focus is p, or 1, 0. The directrix is going to be x equals -1. And our latus rectum points are p, which is 1, plus or minus 2 times 1 is 2. So our focus is at 1, 0. Our directrix is a vertical line this time. And then from our focus, we go over to, up to, and back to create our parabola. Last thing we're going to do is create the equation from some given information. In this one, we are given the focus and the directrix. So our focus is 0, 3, and our directrix is y equals -3. So if we look at our chart here, when we have 0, a point, we're on this bottom one here. 0 number, that means p is 3, and it's going to be in the form x squared equals 4py. So if p is 3, we're just going to plug that in. X squared equals 4 times 3 times y, which means x squared equals 12y, and that is our equation. So we're really just looking at our focus. That's going to tell us what our p is and which of the two equations we're working with. So in B, our focus is -1, 0. That means p is -1. So we are going to look at which of the focus ones has p first, and that's this first equation of y squared equals 4px. And then we will plug in p, which is -1. So we get y squared equals -4x, and that is our equation. Last one, our focus is 3, 0. That means because all of these have their vertex at the origin, that p is equal to 3, and that's going to follow the one we just did, that y squared equals 4px version. So if we plug in p is 3, we have y squared equals 4 times 3, or 12x. The next set of parabolas we're going to work with do not have vertices at the origin. So the equation is going to look a little bit different, and we're still going to have a p, and that is going to still help us determine our focus, directrix, and latus rectum, but it is going to be slightly different here. So we're going to have a different table of information when we are not starting at the origin, because this one's going to have a specific point that is HK as the vertex, which can be taken from our equation. It's still going to be in the form of you've got your variable squared on one side, 4p, and then the other variable on the right side. But it is going to have a little bit more work involved here. So we are going to graph some of these parabolas here. The first one says we want to graph the parabola y plus 3 quantity squared equals -4 times x minus 4. So a few things we're going to do. We're going to pick out the vertex, and the vertex is always in the form hk. So it's going to be the opposite of what's listed inside of here. So if it's x minus 4, the x coordinate is +4, and if it's y plus 3, the y coordinate is -3. Next, I need to find p. Well, I'm going to take what's in front of here and set it equal to 4p. So -4 equals 4p. I divide both sides by 4, p is -1. So now I'm going to look at which one this follows, and that's the top one. So I'm going to find my focus next. So it says to take the first coordinate and add p. So if I have 4 and I add -1 to that, that's going to be 3. -3 as my focus. So our directrix is in the form x equals, take the h value and subtract p. So 4 minus -1 gives me 5. And then we're going to get our latus rectum points here. So we're going to take h plus p, which is that 3 value. And then we're going to take the k value plus and minus 2p. So I'm going to take -3 plus or minus 2 times 1 is 2. So that's going to be 3, comma, what is that going to give me? -1 is the first one, and 3, comma, -5 as the other one. And we're just going to plot all those values. So 1, 2, 3, 4, -3, there's my vertex. The focus is 3, -3. The directrix is x equals 5. So I'm going to draw that dashed line there. And then the end of my latus rectum points are 3, -1, and 3, -5. So we went 1 to the focus, and then it's going to be double that up, double that down. All right, we're going to do the next one here. If you have x, the quantity x plus 5 equals 1/16 y minus 4 quantity squared. So we do not have the squared piece solved for itself. What I need to do is I need to get rid of that 1/16. So what I'm going to do is multiply through by the reciprocal. And what that's going to give me is 16 times x plus 5 equals y minus 4 squared. And if you want to rewrite it the other way, y minus 4 squared equals 16x plus 5. So this is going to look just like the other one here. So let's first pick out the vertex. So the x coordinate in here is plus 5. It's going to come out as negative 5. The y is negative 4 is going to come out as 4. If I take what is in front here and set it equal to 4p, so if 16 equals 4p, divide by 4, p is 4. So to find my focus, I need to add p to my x coordinates. So negative 5 plus 4 is negative 1. And so if you're thinking about that here, so 1, 2, 3, 4, 5, 1, 2, 3, 4. So negative 1, 4. There's your focus. So from your vertex to focus is 1, 2, 3, 4 units apart. I'm going to have 4 units apart the other way as well for the directrix. So the directrix is going to be 4 units this way. So that's going to be x equals negative 9. So let's see, I'm going to have to, we're at 5, 6, 7, 8, 9. So I'll do my best to get my line in here. And actually, let's keep going. Let's do the latus rectum. So we're going to take that focus coordinate, negative 1, and then we're going to take the 4. We need to add and subtract 2p. So add and subtract 8. So negative 1, that's going to be 4 minus 8 is negative 4. Or negative 1 and 4 plus 8 is 12. So my graph isn't the best here, but negative 1, 1, 2, 3, 4. All right, negative 1, we're already at 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops, sorry. We're at 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12. And then I would be able to connect them here. The other thing I could have done is I could have scaled my axis by 2s, and then that probably would have gone a little better here. So what I could do instead is actually count by 2s. So 2, 4, 6, 8, 10, 12. 2, 4, 6, 8, 10, 12. So 2, 4, 6, 8. So you can see that we're going to count by 2s, and then it may go a little bit better. So 2, 4, 5 is going to be in the middle. Negative 1, 4. Negative 1, 12. Negative 1, negative 1. And then you would be able to see that I could draw that a little bit nicer on the graph. We have x plus 4 quantity squared equals negative 18 times the quantity y minus 3. So now we're working with the second option here. So the first thing you can do is pull out my vertex. The x coordinate, it says x plus 4 is going to be negative 4. The y says minus 3 is going to come out as positive 3. So next is going to be the focus. The focus is negative 4, and then I'm going to, I need p. So negative 18, if I set that equal to 4p, and I divide by 4, p is 4.5. So negative 4.5. So the focus takes this. What we have, 3 plus negative 4.5, that's going to be negative 1.5. All right, so my directrix is in the form y equals, take k minus p, so 3 minus negative 4.5 means 3 plus, so 7.5. And then the latus rectum is going to take the h value plus or minus 2p. So negative 4 plus or minus 2 times 4.5 is 9. And this one's going to be, okay, 3. Sorry, 1.5. Negative 1.5. I wrote the wrong value because it's from the focus. K plus P from the focus value. Negative 1.5. Let's see. So if I do that, negative 4 plus 9 is 5 and negative 1.5. Negative 4 minus 9 is negative 13 and negative 1.5. So I'm going to count, let's see, I'm going to count my x's by 2's because I have to go all the way to negative 13. So negative 2, negative 4, 6, 8, 10, 12. And I'm going to keep my y's counting by 1's. 1, 2, 3, 4, 5, 6, 7. So start negative 4, 3. Negative 4, 1.5 is my focus. 7.5 is my directrix. All right, then I've got 5. And, oh, I need negative 1.5. Darn it, it's down here. Let me pick a different value. All right, so vertex, negative 1.5 is down here. Negative 1, negative 2, negative 1.5. All right, so then I need 5. 2, 4, 5, negative 1.5. And negative 13, negative 1.5. And do know you are able to double check these in something like Desmos or your graphing calculator, just to make sure that you have done it correctly. The last thing we're going to do is take our information given our focus and our directrix and go back to our equation form. The first one says our focus is negative 8, negative 2, and the directrix is x equals 6. So the x equals directrix is this top one here. So the x equals h minus p. So that means 6 equals h minus p. That also means from our focus, the negative 8 is h plus p, and our k is negative 2. So what do? Well, we know that right between our focus and our directrix in the exact middle is our vertex. So one option you could do is draw it out. It's for negative 8, negative 2. So 1, 2, 3, 4, 5, 6, 7, 8, down 2. And your directrix is at 1, 2, 3, 4, 5, 6. We know our vertex has to be in the middle of those two values, negative 8 and 6. So really what we're doing is we're looking for the middle or the average of those two values. So to find h, what we're going to do is take the two coordinates we have of negative 8 and 6, add them together, and divide by 2. So if I do that, I'm going to get negative 2 divided by 2, or negative 1. So negative 1 is the exact middle, or my h value. I need h and k to be able to write my equation. Y minus k, well, k is negative 2, so that's going to make plus 2 squared, equals 4. We need to figure out p, so I'll come back to that in a second. And then x minus the h value means minus a negative 1 is plus 1. All right, so the last thing is, well, how do we find p? Well, p is the distance then between your vertex and your focus, or your vertex and your directrix. Well, how far apart are negative 1 and negative 8? They are 7 apart. Now, your graph is going to open this way, and from your vertex, you went back 7 to get your focus. So we went negative 7 to get our focus. So P was negative 7. So our final answer, y plus 2 squared, equals negative 28 x plus 1. Let's try the next one. We have our focus of negative 6, 5, and our directrix of y equals 9. So this time we're going to work over here with the y coordinate because that's what we have. We have our focus is at a y value of 5. Our directrix is at a y value of 9, and we need to find the middle. So we're going to know that h is here, negative 6. This is k plus p, and this is k minus p. So we're going to work backwards to find k. That's the exact middle of 5 and 9. If I take 5 plus 9, I'm going to get 14. And if I divide that by 2, I get 7 for my k. So I have h is negative 6, k is 7. I need to get p. So p is then how far apart are these two values? 7 and 9 are a distance of 2 apart. So I can go to my formula now. This one's an x minus, let's just start over. X minus h, well, h is negative 6, so that's going to be plus 6 squared. 4 times p is 2. Double check that. Is that positive or negative 2? Let me think. We went from negative 6 as the x. Which way are we opening? We went, sometimes I got to draw it out here. Negative 6, 5 is the focus. And then up higher is the directrix. So we're opening down. We're opening down. This is a negative 2. And then we've got y minus the k value is 5, quantity squared. So this will be x plus 6 quantity squared equals negative 8 times the quantity y minus 5 squared. One more. We have a focus of negative 3/2, 7, and a directrix of x equals negative 5/2. So if our directrix is x equals, we're going back to this top one here. So what I need to do first is find the exact middle of the x values. So the exact middle of negative 1.5 and negative 2.5 is negative 2. So negative 3/2 plus negative 5/2 divided by 2 is going to give me negative 2. K is the 7 here. And then we need to figure out how far apart they are. So to find P, remember that our focus is H plus P. So one way to think about this, H is negative 2 plus what gave me negative 3/2. Well, I added, I'm at negative 2, and I want to get to 1.5. I added a half. So we've got all of our pieces now. I can go to my formula. Y minus k, 7 squared, equals 4 times p, 1/2. Open parentheses, x minus h. H is negative 2, so plus 2. And I understand that these may be a little frustrating at times. They're going to take some practice. You're going to have to work at them and really just use this chart. You don't have to have it memorized, but use the functions, use the equations to be able to find the pieces so you can write your equations. That is the end of this section.